Welcome to Inference for Categorical Data Part 2. Okay, so in this part of the lab, what we're going to do is we're going to go take a look at exercise 6.6. The 2010 healthcare law hasn't been the least bit controversial, right? Okay, so in June 28, 2012, it went to the Supreme Court for the first time, which upheld the much debated 2010 healthcare law, declaring it constitutional. Gallup poll released the day after this decision indicates that 46% of the 1,012 Americans agree with this decision. At a 95% confidence level, this sample has a 3% margin of error. Based on this information, determine if the following statements are true or false and explain your reasoning. Okay, so before we get into the true false here, let's go dissect a little bit what was given here. So our n, or sample size, was very big. It was 1,012. And one of the things that you should notice that is a commonality in Gallup and other polling companies, that they tend to use a sample size of around 12 to 1,500. It's pretty common. It's definitely going to be bigger than 1,000. Why? Because that sample size drives the margin of error for them. That's how they get the 3% margin of error. If they want that margin of error to be smaller, then they need to increase their sample size. So let's talk about the CI here for just a second. Let's go over to the whiteboard and let's go ahead and talk about what does that confidence interval look like. Well, we came up with a sample proportion, a p hat, that was 46%. So p hat is equal to 46%. That is our point estimate. And then the margin of error that was given to us, that was equal to 3%. So we know that the 95% confidence interval that they were stating there is going to be given to us by our p hat plus or minus our margin of error. That's how you would calculate the confidence interval. So that's going to be 46% plus or minus 3%. So you now are part of the 10% of America that understands what the heck that margin of error means, where it actually came from. So just a quick aside to remind you, we know that the margin of error is equal to what? Well, it's the number of standard deviations, which in the case of the population proportion confidence interval is going to be given by Z star times our standard error. And that standard error in the case of the proportions is going to be given by the square root of the p hats times 1 minus the p hat divided by n, square root of all that. And again, this is just like when we calculated the standard error when we're working with means. We have to use our sample value in calculating that standard error, but provided that the sample size is large enough, that's going to be a right fine, pretty darn good guess of what the standard error is. Okay, and remember that Z star, that's determined by the level of confidence. The 95% told us that we're working in the standard normal distribution Z here, and so we know that we're going to be down here at negative 1.96 and up here at positive 1.96, basically 2 standard deviations either above or below the mean. Okay, just our empirical rule one more time. So anyway, if we were actually to write out the confidence interval, that would say that somewhere between 43% and 49% of Americans agreed with the decision that was handed down by the Supreme Court. Okay, hopefully that's kind of cool. Yeah, real world application of the stuff that we're learning. Oh my gosh. Okay, so let's go back here and let's go ahead and see if we can answer the true false questions here. So the first one, it says we are 95% confident between 43 and 49%. Now we know where those numbers came from, of Americans in this sample. Oh, you guys. It was going so well until they said sample. A confidence interval is not about a sample. A confidence interval is about a population. So what we would be inferring is something about the population of Americans. So this is false. I'll stay in all caps here just to emphasize it. A CI is about a population, not a sample. Okay. Trying to mess with us again. Okay, so these questions should be looking somewhat familiar. We had very similar questions thrown at us in the last chapter when we were talking about confidence intervals for means. Okay, so part B, we are 95% confident between 43 and 95% of Americans support the decision of the U.S. Supreme Court in the 2010 healthcare law. There we go. Because what was our population of interest here? It was the population of Americans. So this is true. As a matter of fact, this is our boilerplate for how to report a confidence interval. And we talked about that in the last chapter. So that's how, when you report a confidence interval, that's exactly the sort of sentence that you would use. Okay. All right. So what about part C here? If we considered many random samples of 1,012 Americans and we calculated the sample proportions of those who support the decision of the U.S. Supreme Court, 95% of those samples, they're messing with you here. That's not what the 95% means, right? The 95% says that in repeated sampling, 95% of the confidence intervals would capture the population proportion and 5% of them would not. So again, they're just twisting the language here on us to see how we're doing this. This is false. Again, a CI is about the population, not about a sample. Okay. In other words, confidence intervals are estimates for the population proportion. They're not estimates for the sample statistic. Okay. All right. So the margin of error of a 90% confidence interval would be higher than for a 3%. Ooh, that one's a little counterintuitive. It turns out that that's false, but I'm going to go to the whiteboard to explain to you why. Okay. So let's go over to the whiteboard and draw a little bit of a picture here, and maybe that'll hopefully make a little more sense why that one is false. So let's go ahead and clear out all of this. And so let's draw ourselves a standard normal distribution here, thinking again about the empirical rule Z here. So we know that we're centered at 0 here. So in a 95% confidence interval, which is the one that was given to us, we were up here at what, 1.96, and we were down here at negative 1.96. Okay. Well, we know from our previous work from the last chapter that a 90% confidence interval, well, that's going to be narrower than a 95% confidence interval, because we're now only going less than 2 standard deviations above and below. In fact, we know that this is negative 1.65 and this is a positive 1.65. Okay, so that means that my value of Z star is going to differ for a 90% CI versus a 95% CI. So let's be more explicit about that. So if we're talking about a 95% CI, that's not an E there, that's an I. Oh, let's go to that little bar in the center there to make it look like an I. There we go. Okay, so a 95% CI, then the margin of error, how would that be calculated? Well, again, it's going to be the number of standard deviations times the standard error. So that's going to be equal to 1.96 standard errors, isn't it, right? So it'd be 1.96 times the standard error. Well, in a 90% confidence interval, standard error isn't going to change. We're assuming we have the same sample, but now our margin of error is going to be equal to what? It's going to be equal to 1.65 standard errors. So what would that mean about our margin of error? Well, notice that this number right here, the 1.65 standard errors, that's going to be less than 1.96 standard errors. In other words, 1.65 standard errors is what? Well, that's less than 1.96 standard errors. Remember, those are both margins of error, aren't they? Okay, so the margin of error for the 90% confidence interval is going to be narrower. So if you think about your margin of error as being the width of your confidence interval, then it makes total sense, because in a 90% confidence interval, it's going to be a narrower confidence interval. It's not going to be wider. Again, review from the last chapter and all the stuff that we talked about in chapter 4 also. Okay, let's go back to our studio here and let's take a quick peek. See, I think we might have nailed them all. Yep, we got them all. We just got to finish typing up what we said there, and we go, no, the CI will be narrower And so the margin of error will be smaller. Okay, so the last video was really long, so I'm going to make this one short so you can get a little bit of a break here, okay? So review the stuff, and I'll be back soon.